Hi, hello everyone, welcome to the channel. So in this video I'm going to show you how to extract the rainfall data using random sample points from CHIRPS data in Google Earth Engine for any study area. So now to extract the rainfall data for any study region, first we have to load our country's boundary layer into Earth Engine. So to load our country's boundary layer, we defined a variable called countries equals to feature_collection USDOS LSIB simple 2017. And next we define a variable called ROI, which represents our region of interest, equals to countries.filter filter.eq country name. So here our study region will be our India. So that is our region of interest will be India. So next, to add this layer, we define map.addLayer ROI that represents our region of interest with the default visualization parameter and output the layer name as India. And next, to center this particular layer, we define map.centerObject with a region of interest with a zoom level of 4. Next, we have to insert our CHIRPS data, that is our rainfall data, into our Earth Engine. So now let me explain about this data here. So this is our CHIRPS data, that is Climate Hazard Group InfraRed Precipitation with station data. So here you can access this particular data using the specific code here mentioned. So the resolution of this particular data is around 5566 meters. So let me show the description. So it is a CHIRPS data is the 30 plus years of global rainfall data. So it incorporates 0.05 resolution satellite imagery with the in situ station data to create a gridded rainfall time series for trend analysis and seasonal drought monitoring. So using the specific set of code, you can access this CHIRPS data. So now let me get back to my Earth Engine here. So to insert the CHIRPS data, we defined a variable called CHIRPS equals to image_collection UCSB SHG CHIRPS pendet.select precipitation. So we are using this specific band here, that is precipitation band that is available in this CHIRPS data. So we are selecting this particular band, that is precipitation band, and filtering with a specific timeline that is mentioned from 2023 January 1 to 2023 December 31st. Next up, we're going to reduce our image collection to one image by summing the 365 daily raster images from the CHIRPS data. So for that, we define variable annual CHIRPS equals to CHIRPS.reduce w.reducer.sum. So we are summing up for the entire year of 2023 into one image. So to visualize the particular details of those images, we define print annual CHIRPS. So it basically reduces the image collection to a single image by summing up all the images in the collection, and the result is the annual rainfall image. So next, to create our visualization parameter, we defined a variable called vis. We are setting with a minimum value of 0 and to a maximum value of around 3500. We are setting a color palette with this particular color palette represents the lowest level of rainfall, and this set of color palette here which represents the highest level of rainfall. So this sets a visualization parameter for displaying our annual rainfall data in our Earth Engine. So next, to add our annual rainfall map for this particular region of interest, we define map.addLayer and annual CHIRPS.clip. We are clipping with a specific study region, that is our region of interest. It is our India, and we have set our visualization parameter. This specific represents our visualization parameter here, and output the layer name as annual rainfall. So next, we are generating our random sample points extraction. So for that, we defined a variable called projection equals to annual CHIRPS.projection function. So next, we are using variable scale equals to annual CHIRPS.projection.nominal scale function. So this particular is the samples the annual rainfall image at the random points within the boundary of our study region. So next is we are using a variable called rainfall samples equals to annual CHIRPS.sample. So the region is our region of interest, that is our study region ROI, and the projection, we defined the projection here, scale, and the geometric set to true. So the projection scales are defined based on the projection of our annual rainfall image. So next, to add this layer, we define map.addLayer rainfall samples. So this specific variable refers to this particular variable here, the rainfall sample, with the default visualization parameter. and output the layer name as points extracted. So basically it adds our random sample points to our map, and next is add a properties to our output table. So we're gonna add a 3 properties here, that is our rainfall, rainfall data, and our longitude and latitude. So to do that, we define the rainfall samples. We are referring to this specific variable here, rainfall samples, and equals to rainfall samples dot map function features. So here the variable geometry equals to feature dot geometry function dot coordinates. And next we are returning dot doubly dot feature null. So here the rainfall is doubly dot number feature dot get precipitation sum, and the longitude refers to doubly dot num geometry dot get 0 refers to our longitude here, and similarly the latitude doubly dot number geometry dot get 1. So this section transfers the sample points into a feature with the desired properties, and to print a first set of sample points along with their rainfall values, latitude and longitude. So to view that information in the console section here, we defined a print rainfall samples dot limit. We are set to a limit to 10. So initially we are setting a limit to 10. So to view our sample points here in the output section. So let us run this code. So navigate to this option called run script, and we're gonna click run. So here in the first output section here, the image represents the bands. So we have used our precipitation band. So it represents the precipitation sum with the data format and the projection. And next is the feature collection here. So we have our features, 10 list of features here. So we have defined it with the rainfall sample dot limit of 10 represents our 10 different rainfall values with latitude and longitude. So here you can take a look at this. We have a latitude, longitude and rainfall data for the specific study region. So for 10 sample points here. So you can able to view here. So now let us take a look at the map here. So here you can able to visualize from this map. So we have a 0.6 that is a random point sample points, and annual rainfall, and the study area boundary has defined this layer. So let me turn off this particular layer here. So here you can able to visualize the highest level of rainfall being received are indicated in the series of red color here. You can able to visualize in this portion of the western areas of this particular study region, India. You can visualize a higher level of rainfall being received in this part of the region, which indicates that there is already an existence of Western Ghats mountain ranges, which results significantly a higher level of rainfall being falls in this particular study area here, which is indicated in red color, and the blue area indicates the lower amount of rainfall. So the highest level of rainfall being indicated in red, and the lowest level of being indicated in blue, and the moderate level of rainfalls are indicated in yellow and green color. You can able to visualize it. So similarly, let me turn off this layer. This is our study area boundary layer, and this is our annual rainfall layer, and I'm gonna turn on our random sample points for the study area here. So you can able to visualize it. We have created a number of random sample points from our study region, and I've shown you in that I have only extracted 10 sample points with the latitude, longitude and rainfall data from our annual average rainfall map. So in this video I have shown you, and the purpose of the script is to extract the rainfall data at the random sample points within the boundary of our study region using our CHIRPS data and visualize it on map. And I've shown you 10 sample points from the study region with the latitude, longitude and rainfall data of the study region. So in this video I have shown you how to extract the rainfall data using random sample points from CHIRPS data in Google Earth Engine for any study area. So thanks for watching, and please subscribe to our channel and give us a like.